Hi, I'm Patrick from NorthOne. I'm a full stack developer. I'm working on the GraphQL gateway as well as on the mobile team. So we're building a banking platform for small businesses. So we're building a pretty sweet mobile app. If you want to talk to me, just find me on LinkedIn. I wish I had Twitter or something. I'm a developer, should have one, but find me on there, or that's my email, or just talk to me after. So today I'll talk about what a GraphQL gateway is, how do gateways work, and our experience at NorthOne designing our GraphQL gateway, and how we organize our code and use our tools. This is something that we've been evolving for the past few months, and I haven't seen too much material up until recently, so hopefully I can enlighten some of you. So what is a GraphQL gateway? So I like to think of it as like a single service with a query interface that talks to all of your data sources. And so a data source could be anything: REST API, database, mock data, markdown file. And you probably all know what GraphQL is already, so if you don't, basically your mobile app just sends one query over the wire, and then the server basically resolves it to a bunch of different data sources and returns back one payload. So these are some of the companies using a GraphQL gateway in production right now. So Medium, I believe, is using Scala. Netflix, I think they're using Apollo. Airbnb is definitely using Apollo. So is Audi. Audi's doing some interesting schema stitching stuff. And I really want to highlight Airbnb. So they're very invested in GraphQL and the Apollo community. So they're working closely with the Apollo open source team, developing lots of tooling. And they're not only using it to lead their API design, they're also using it for their internal design tools. Their product managers are using it, and they're actually generating views from their backend in their React code, which is super cool. And they have all these CLI tools. There's an awesome talk at this year's GraphQL Summit about it, so I highly recommend that. So how do GraphQL gateways fetch data? So if we start with this beautiful mock, this is our app actually, NorthOne. Typically, a developer will write a query that matches up with that mock, so you could see where the data is coming from in each case. And our GraphQL server will reach out to various endpoints. So this is a case where we're using a bunch of REST APIs. So if you weren't to ask for accounts, for instance, right here, then we wouldn't even reach that REST API. And so you're sending one query over the wire asking exactly what you want, and then you're only getting that data back. So these might be massive payloads coming back from each API, but we're only getting those fields back. So if our product manager comes up to us and they're like, hey, we want notifications for support, the way we would develop that is the API developer, or sorry, the front-end developer just grabs a field. They're like, here, I just want support ticket count, and the GraphQL server will connect to a third-party API. So the front-end developer doesn't have to know anything about Zendesk, about their API documentation. We can just design that. What if this is the only use case we want Zendesk for in this particular application? We can abstract all that away into this nice API layer. And this, I guess I didn't compare a traditional GraphQL approach, but the API gateway is different from a traditional approach in that sometimes you'll have one big backend that feeds your resolvers. In this case, we're using all kinds of data sources. So this is what this looks like in code. So I'm sure you guys are familiar with GraphQL. The top is our schema. So think of it as a data contract, and below is our resolvers. And so if you look over here, each one of these resolvers just returns data from a different data source. So the top is just an HTTP request. In the middle there, we're requesting directly from a database. And the last, we're requesting Mocky McMockerson from our mock file. And we're just matching these exactly to these types. So these are just function calls, basically, and they could return anything we want. And each one of these could request 10 data sources, stitch things together, manipulate data, and then return something back. So GraphQL at NorthOne. So we're building a mobile app, and we're using an Apollo server gateway. And this is what our architecture looks like. So right now we're working with a monolith because it's easy to get off the ground and understand our entire business domain first. And so if you notice here, we have one request. The color matches up to that monolith API. So we're performing 3 requests to this one service. And so this is all on a private network. So this one request may be at a different geographical location, could be at the other coast, but right here, when we're actually resolving this, we're fetching these locally. So these are super quick requests, and then they're coming back as one request. So typically, if you're developing with a bunch of REST microservices, you might reach out to 3 endpoints, and these are 3 maybe coast-to-coast network calls that aren't that performant. And then here, I put Zendesk a little further out because this is a cloud service. So we have a combination of our internal services and cloud services. So if performance becomes an issue here, we can actually delay the resolution of this query till later, to this field. So we can actually resolve things quickly, show that data to our clients, and then eventually get back the support ticket count there. What's really cool about the gateway pattern is we can just divide these all up into microservices. So once we understand our domain a bit better, we can divide up into microservices, and each microservice can focus on what it does best. So all of the authentication, error handling, everything can be done independently or pulled up into the GraphQL gateway. And something I didn't mention before is I put this kind of on the edge, so we consider this an edge service. This is the only entry point into our infrastructure. So all of our clients can talk to our GraphQL API, but everything else is internal. So our experiences. So we eventually embraced client-first design. So GraphQL is new, and we were all sort of discovering things as we went. So we already had most of our backend built out. So it's easy to go from models and our REST endpoints and just developing an API. And then also when we were doing product management, we were creating tasks like CRUD for a user, CRUD for a transaction. And we found that wasn't actually leveraging GraphQL the way we wanted. So eventually we decided to go from mobile prototypes. We had a full prototype ready to go. So we just went from there, looked at our business domain, and just did an iterative approach. And we just really satisfied the client and didn't worry about implementation details on the back end. And so we decided to make data presentable as is. So the first example I showed here, this is our screen. We're fetching some transactions. And so if we're just fetching transactions like this, that looks fine, but as you start to develop this app, as a mobile developer, you may realize these are all grouped by date. And we didn't account for that here. So either the mobile developer can transform that data, and then if you have a web app, you have to transform that data again. Instead of doing that, we can actually enable the mobile developer to display the data as is. So in this case, we're returning transactions already grouped by date. We could still have a transactions field on here as well. And so now you can specify, I want all the transactions from the beginning to the end of the month. I want to order them ascendingly, and I want them keyed under date. So now you can just develop this feature as is. Even a product manager could be like, hey, I want this to look like this, and we can build it. And so that made us develop really, really fast. Another interesting thing is pulling business logic into the gateway. We have a lot of power here. So text is kind of small, but basically here, this is a selection screen where we want to pre-select a few of these inputs based on whether this user, D'Angelo, has access to a business. And so typically, you might get back a business which has a bunch of readers on it, and you might actually map through those and figure out if they include the email that we already have. But what we can do instead is we can actually put a has reader field right in our GraphQL API using a parameterized field. So now, instead of having this code here and needing to test it on the client, and maybe if you have multiple clients, you have to do it 3 times, maybe it's not tested well, we can put it right into our data fetching layer and keep it in one place. So that made things much more maintainable. And again, speed, it made us a lot faster. So in the theme of speed, we didn't want to wait on the back end to be code and feature complete on the client. So like I mentioned at the beginning, we had full prototypes done. So one cool thing our company did was before I was hired, they already did like 300 customer interviews. We already had a fully functional prototype, a click-through prototype. So you can share this link and it looked like a ready functioning app. So as mobile developers, we were anxious. We wanted to do everything. And the backend was developed, but there's still lots of things we needed to figure out because we're working with financial service companies, lots of contracts and things. So we wanted to get developing really quickly. So what we were able to do is do things like leverage existing endpoints to get new functionality. So suppose we have a conditional operation on our loading screen where we want to know if a user is fully onboarded. So we're developing a financial service. We need to do background checks. We need to check that a user is billed. We need to check if they've actually filled in their user details. So instead of waiting for our compliance partners to come through and making sure we know everything, we were actually able to develop this ahead of time. So we would be able to use a subset of our endpoints and stitch things together. So in this case, we're reaching out to 3 different endpoints. And then our resolver will combine this and then figure out what the meaning is there. So this is just going to return a Boolean. That's all our mobile team cares about. And so now let's say we're waiting on one more compliance partner or something. That's logic we could put in later, but for the time being, we're OK. And going one step further, we can also return mock data. So we ended up doing this a lot. So why don't we just return a Boolean here? And so this is totally valid. So now your client can be feature and code complete, because you're actually fetching real GraphQL queries, but our data isn't fetched right from our backend services, which is fine because eventually once we flip that switch, our mobile app is ready to go. So an interesting thing was that GraphQL was a great communication tool. So the SDL language is just so easy to work with, and we also found that developers found it very intuitive. So a mobile developer would come to us and be like, hey, we want this functionality on our screen. It looks just like the mobile prototype. Can you make this happen? And we often could make it happen. Also, it serves as a good contract between the front end and the back end teams. So we can agree on something like, we can fulfill this contract and let's do it. That goes into a story in our product management system. And oftentimes now we can just work in parallel and not worry about each other, not step on each other's toes. Some of the challenges. So mobile no longer adapts to the API. So typically, if you have a bunch of REST services built out, there isn't much room for change. So it's a little bit rigid. Here we were very flexible. So at first, we didn't know how far to go. And there's like a lot of back and forth. So figuring that out. Team structure was also a little difficult at first. So when we started out, it was part of the mobile team. I was a mobile developer and a GraphQL developer. And we were sort of developing in tandem. Now we're starting to branch out, and we match up a GraphQL developer with a mobile developer. And it's new, so I already mentioned that. Some of these best practices haven't been established yet. I'm here to sort of bring some of what we've learned forward, but this year has been awesome. Some of the conference talks were really good. I really recommend watching the summit talks this year. They were just absolutely amazing. And testing, so testing was very difficult to figure out. It's hard to figure out like what was a unit, what do integration tests look like, do we test the entire resolver chain, do we test every error case, do we test business cases, do we use Cucumber, and then also end-to-end testing, what does that look like, and then now into bringing mobile into the equation. And actually there's a really cool talk by OK Girl, it's a shout out to OK Girl, at the GraphQL Summit, and they were talking about contract tests. So GraphQL can be this sort of contract where your front end and back end could satisfy what looks like an end-to-end test, but it's not quite running all the way through. I want to talk to Paul about that after, because I don't fully understand it yet, but really, really cool. So we're figuring these things out. So testing is one of those things that's still up in the air, but we're learning a lot. So why we chose GraphQL, so I already talked about this, speeds up front-end development. Like we were able to rip right through our entire prototype within a couple months just because we were able to mock out data where we needed, and now we could just plug things in where we need to go. Client-side performance, so that idea of being able to just fetch one request, which hits all of your local endpoints, makes things a lot faster. You're also getting a smaller payload across the wire, so that's also faster. And then there's all kinds of front-end tools that help us. So we use Apollo Client, and you could just run one big query at the beginning of your app to load everything in, hydrate your cache, and your user experience is seamless. And then you could just always load from that cache and then fetch in the background to make sure nothing's changed. Also, there's all kinds of per-field caching and other things that we could do that we haven't really explored yet. And developer experience, so this is my favorite one. I absolutely love GraphQL. Just hopping to the playground and knowing where to find all my data was just amazing. So I found that we had this, it was really easy to onboard developers, so we had this crunch period where we needed to throw the whole team onto our mobile team. So even backend developers hopped in, and so they were familiar with some front-end code, but they didn't know anything really about our APIs. This is backend, like developing REST API backend. And they were able to just look into the playground and figure out where everything was. There wasn't really any tribal knowledge or anything. Everything was discoverable. So the developer experience was really awesome. And then all the code generation tools we were able to use is awesome too. And then backend flexibility. So I showed how we can just move from a monolith to a microservice architecture really quickly. And that's something we're really excited for, because as we're building we might build more services into our financial product, and we want the ability to just build out a billing service or a loan service, and then just let them do what they do best. So we could do that without the client ever having to worry about anything. So this is for those who use Apollo Server. So, not this necessarily. So this is our tooling. I'll link the slides after so you can take a look. The one that may not be familiar here is Joy.js. So we do object level validation. So you could just write out what your object looks like, and in our resolvers we could just check those instead of writing functions to check those manually. That was actually a really cool tool. But how we organize. So we started off with one big schema to figure out how to piece apart our business domain. And so we eventually organized everything by feature domain. And these weren't mapped to the backend, so it's easy to look at your backend models and choose, I want to organize by users, transactions, etc. But eventually we just decided, let's do what actually works for mobile and in our business domain. So each domain has a set of type definitions, your data contract. It also has data sources. So this is our interface between our backend code. Resolvers, so yeah, they call the data sources to fulfill the contracts. And then we have one big schema. So even though we have these separated, so you might have a bunch of features, at runtime we're actually working with one big document. So we just export that as one schema. And so there's schema stitching. I won't get into that today, but that's the idea of actually developing separate schemas, maybe even separate apps, and then pulling them together and surfacing them as one API. So the way we dealt with data sources is we treated them as interfaces for our backends and resolvers, or between our backend and resolvers. So within the resolver, you shouldn't have to know about your various backends. You shouldn't have to know about endpoints, error handling, tribal knowledge. You should just be able to call it with a very nice API. So we were able, and that's going with the theme of we want to switch eventually to a microservice architecture, and we could do that without changing resolver code or resolver test code. And then now resolvers have a single focus and they're very lean. And so this is what that looks like. So the ideal case here is you're just looking at your data sources, give me a user and get that user. Sorry, access the user data source and get that user. Versus here, we have to know about the API, and then what if you change that endpoint one day? You have to go in here and change that. And then here we're actually mapping over the way our data is returned from the backend, and we're actually changing the case. In this case, we're actually creating a name out of first and last name. Another cool thing we could do with GraphQL. But this is all stuff we want to do in the data source, because if we're changing the way those work, our resolvers will never have to change. So this is something we started doing fairly recently. Well, the hard division ended up being fairly recent, but we've basically migrated to this solely. And so I mentioned I was going to talk about Apollo REST, I think, in the talk description. So I'll go over this very briefly. Essentially, this helps us achieve that separation of concerns. So Apollo REST data source, it's just an NPM package, and it's an HTTP client that provides some caching and helps you encapsulate your endpoints. So here you could just set common properties like your base URL, and you declare all your methods and pull in all of the logic that you would want to abstract away from your resolver into here. And then when you're actually calling this data source, we're returning objects that are ready to use in GraphQL. And so this is that data source in action. I already showed this, but again, just showing how simple it is to use something like this. TypeScript and GraphQL. Are there any TypeScript users in the audience? Okay, yeah. I'm not going to sell you on TypeScript today, but we absolutely love it. And so I'll explain why we use it. So yeah, we could catch more errors at build time instead of runtime, so our production code isn't going to be full of bugs. Especially in GraphQL, where you're mapping over like return types from your API to GraphQL, changing undercase to camel case. We can catch all that before we even write tests while we're coding, especially with code generation tools. So I honestly think it's a no-brainer if you're working with GraphQL, but that's just me, and I love TypeScript. And it allows us to iterate without losing customer confidence. So we're building a financial service, and so if we mess up transactions for our customers, or even just make records look wrong, we're going to lose customer confidence, we're going to lose customers. And our team really cares about code quality and developer experience, and TypeScript provides auto-completion, and just as you're coding, you can see the errors you're making, and a lot of confidence. So if you want to hire new developers to your team that don't know a lot about your production, that don't know a lot about your code base, they will actually catch a lot of the errors as they're coding, and they can learn your code base and not make tiny little errors that they wouldn't even expect to. So we found it was very easy to work with on the client. So Apollo released the CLI for front end for their Apollo client, which just looks through your project structure and generates types beside the queries you define. They didn't actually release something like that for the server, which was very painful at first because we started off manually mapping over our types. So we had to actually convert these to TypeScript. And this is very annoying because if you notice here, string is capital, where in TypeScript it's lowercase. What is this question mark about here? Why is there a question mark or null? And I don't know if you guys noticed, but there's a mistake in here. So right there we missed a question mark. So now we think that our app is type safe, but it's not, because we as developers did not map things over. So really quickly we realized this is not a good solution. So we looked for other tooling. And we finally found a good tool. And so that's me crying and being happy because we were basically doubling the code we wrote for our schema and trying to maintain this, whereas now we could generate this ourselves. And so right now we generate types for our resolvers, our GraphQL types themselves, input arguments, and enums. And it's super easy to set up. So you just specify where your schema is, your output directory, maybe your context if you're using one, and then what plugins you want, and then you just run a command, and this will generate. And you can even watch for changes in your code base. And so this is what an application looks like that uses this type generation. So we hit a command, and now we just import our resolvers, and we already know we made 2 mistakes. So subaccount ID doesn't exist in our arguments, and this is based off of the schema we created. So that, again, that idea of a contract, TypeScript is enforcing our contract. And we didn't return balance. So if you were to look at the type for this, balance would be required. And so we get this all free right out of the box. And yeah, I wouldn't want to develop without it. And so some cool stuff we didn't expect to get. Deploy checks were one of those. So you can publish your schema as you're developing, and you could check it against the schema that you have already published. So now as you're working with a lot of developers and everybody's changing the schema, you can make sure you didn't break anything. And so this is what that looks like. So per field, you can see what's been removed, what has been added. And so on top of this, you also get schema history. So you could see the versions of your schema, which fields have been added, which fields have been removed. And so this is just Apollo tooling right out of the box. This is Apollo engine right here, and you just publish it as part of your CI process, and you can just step through. And it's a good discovery tool for your developers. Somebody asks for something new, Slack them, say check out the newest schema, and you could see what has changed. And so the future, per client checks. So those checks we just looked at do a diff between the schema you just published and the one you're working on. But what if your mobile app or your client doesn't actually use any it doesn't use something that was said that was broken. So we can actually publish all the operations on a client app to Apollo Engine, and then we could check our schema against a specific client. So does this break our mobile app, our main mobile app, or does this just break something we don't care about, or is it not breaking anything? So we can get a little bit further with that, and we're looking into that right now. Schema stitching, potentially. So we can actually use a GraphQL API as a data source. So we can have a REST API and a GraphQL API as microservice and stitch that in. Per field caching, so if there's certain things that are frequently requested, we can cache those specifically. So we're going to look into that. And yeah, like I mentioned, microservice architecture seems very promising, and that's what GraphQL gateways solve. The end, you guys rock. Also, if you want to join us, we're always looking for amazing developers, and specifically DevOps people. If we have amazing DevOps people here, please reach out to me or check out NorthOne, this link right here.